Hello, welcome everyone. Now we are going to deal with wave optics, and in this so called physical optics, and in this first we will discuss interference of light. It is matter of common experience that two trains of ripple on the surface of water cross each other and proceed onward in their direction undisturbed. In the same way, two beams of light cross each other and proceed without being influenced by each other in any way. However, in the region of crossing where both the beam are acting simultaneously, we expect a modification in their intensity which should be either less or greater than that which would be given by one beam alone. This modification of intensity due to superimposition of two or more beams of light is spoken of as interference of light. So what I am telling you is that suppose two waves are going. This one is first wave, this is traveling with v1, and other wave is coming with v2. So after a while what will happen? They will cross. So at the position of cross there will be a modification. This is known as modification, and at this place interference happened. But afterward what will happen? This second wave will continue with same velocity v2, and this first wave will cross and will be move with velocity v1. So these are the beauty of interference of light. But this doesn't happen with the train. Suppose there is a train track on, and a train is going over it, and from other side a train is also coming. So it is not possible, this is train A and this is train B. This is not possible that A will cross B and B will cross A and will pass each other smoothly. Rather they will collide. This is known as collision. So in this, permanent modification will take place. What will happen? Permanent modification will take place. But interference, temporary modification happens. Afterward they each waves pass through each other smoothly. Okay, so when two light, in the context of light, if we discuss in the context of light, when two light waves, when two light waves having, these are our area of interest, same frequency, same frequency, and or nearly equal amplitude are moving. Okay, in the same in the same direction, superimpose each other at some point, at some point, then intensity intensity of light is maximum at some point and it is minimum, and it is minimum at some point, at some another point. This phenomenon is known as, this event is known as what? Interference of light. Okay. Mathematically, suppose we have two light waves, each one have amplitude a1 and a2 respectively. So resultant amplitude will be, what I am telling you is that, suppose this is a wave whose amplitude is a1 and other one whose amplitude is a2. This is in the phase of pi upon 2 and this is in the phase of 3 pi upon 2. So what are you observing? Phase difference is pi. Okay. So phase difference delta phi, or we simply say phi, is pi. So the formula of resultant amplitude, which you have also studied when you were dealing simple harmonic motion. So A resultant, and this is resultant amplitude when they will interfere, will be equal to root under a1 square plus a2 square plus twice a1 a2 cos phi. Okay, where this is of course resultant amplitude, resultant amplitude. So intensity, so far intensity is concerned, is directly proportional to square of the amplitude. This you have been studying since class 9th. Intensity is directly proportional to a square of the amplitude. So I is equal to k times a square, and if k is equal to 1, so this expression in terms of intensity will turns out I is equal to I1 plus I2 plus twice root I1 root I2 cos phi, where phi is what? Phi is phase difference. So these are formula through which you can find out resultant amplitude as well as intensity. Now if I1 and I2, I1 and I2 are intensity of source, intensity of source, and if the distance, comma, if the distance of a source from 2 points A and B is x1 and x2, then path difference delta x is equal to x2 minus x1. So what I am telling you is that this is S and this is point A and this is point B. So this is like this is x2 and this one is at x1. So of course this one is what? x2 minus x1. Okay, so this is known as path difference. This is path difference. And phase difference. Phase difference is equal to 2 pi upon lambda into delta x, because lambda, path difference of lambda is equivalent to phase difference of 2 pi. So path difference of unit is equivalent to phase difference of what? 2 pi upon lambda. So path difference of delta x is equivalent to 2 pi upon lambda into delta x phase difference. Okay, so this is phase difference. And path difference. Path difference lambda, what I am telling you is that path difference of lambda is equivalent to phase difference phase difference of 2 pi. So path difference of 1 unit will be equivalent to 2 pi upon lambda. So this is path difference of 1 unit is equivalent to phase difference of what? 2 pi upon lambda into 1. So path difference of delta x is equivalent to phase difference of what? To phase difference of 2 pi upon lambda into delta x. Okay, so this is phase difference. And similarly path difference is equal to lambda upon 2 pi into phi. Simply use unitary method. So one more aspect I want to say about that aspect of phase difference. This is important fact. Upon 2 pi is equal to path difference upon lambda is equal to time difference. Time difference upon g. So this is very important thing to solve numerical. So what we have already studied, resultant amplitude of interference. Resultant amplitude was what? A is equal to root under a1 square plus a2 square plus twice a1 a2 cos phi. Okay, and resultant amplitude was what? I1 plus I2 plus twice root I1 root I2 cos phi. Okay, so if you want Mx, so Mx will be happen when cos phi will be maximum, and the maximum value of cos phi of maximum value is 1 for phi is equal to what? 0 degree. Okay, that is in same phase. So Mx will happen when both wave will be in same phase. Okay, so what I am telling you is that a result Mx, if we do talk about Mx, so Mx is what? Mx, a resultant was root under a1 square plus a2 square plus 2 a1 a2 cos 0. So this is equal to a1 square plus a2 square plus 2 a1 a2, and this is equal to a1 plus a2. So this is the maximum value. This is the maximum value of resultant amplitude. So, and if we do talk of minimum value, a resultant, if you desire to be resultant to be minimum, for this you will have to be cos phi what? Minimum. And the minimum value of cos phi is what? Minus 1. For phi is equal to what? 180 or pi radian. So of course a resultant minimum is equal to a1 square plus a2 square plus 2 a1 a2 cos 180 degree, and this is equal to root under a1 square plus a2 square minus 2 a1 a2, as cos 180 degree is what? Minus 1, or cos pi is minus 1. So this will turns out mod a1 minus a2. Why we are taking mod? Because this is inside a square root, and of course it will not be negative. Okay, so these are basic stuffs which we have to hold in our head. Now second thing is that Imax, the general formula of resultant intensity is I1 plus I2. This is resultant intensity I1 plus I2 plus twice root I1 root I2 cos phi. If you desire I resultant to be maximum, for this cos phi will have to be what? Maximum. And maximum value of cos is what? 1. For phi is equal to what? 0 degree. So I resultant will become, the maximum value of I resultant will become I1 plus I2 plus twice root I1 I2, and this is nothing but simply root under I1 plus root under I2 whole square. Okay. Similarly, if you desire I resultant to be minimum, for this cos phi will have to be what? Minimum. And minimum value of cos phi is minus 1. For phi is equal to what? 180 degree or pi radian. So I resultant mean will become what? I1 plus I2 minus twice root under I1 root under I2, and this is root I1 minus root I2 whole square. Okay, so overall what conclusion we have drawn is that I max upon I mean is equal to I max upon I mean is equal to root I1 plus root I2 upon root I1 minus root I2 whole square, and this is equal to A1 plus A2 upon A1 minus A2 whole square. Okay, now I resultant was what? I1 plus I2 plus twice root I1 root I2 cos phi if intensity of both source is same. If intensity of both source is same, then I1 is equal to I2 is equal to what? I naught. So I resultant is equal to I naught plus twice root I naught cos phi, and this will be 2 I naught 1 plus cos phi. Okay, and this is what? 4 I naught cos square phi upon 2. Okay, so as far as intensity distribution is concerned, I just want to tell all of you that average value of cos square theta, I average value, if we do talk of average value of intensity, so of course it will be 4 I naught average value of what? Cos square phi upon 2. And for your kind information, I just want to tell all of you that average value of cos square phi upon 2 in one cycle is what? 1 upon 2. So this will turns out what? 4 I naught into 1 upon 2, and this is equal to what? 2 I naught. So what I want to tell all of you is that I resultant was what? I1 plus I2 plus twice root under I1 root I2 cos phi. If I1 is equal to I2 is equal to I naught, in that case I resultant will become 4 I naught cos square phi upon 2. So in that case maximum value of I resultant will be what? 4 I naught. Okay, and minimum value of I resultant will be what? Since this is cos square phi upon 2, so the minimum value of cos square theta is what? 0. So this is what? 0. Okay, so these are the things through which I want to plot a graph, and through which I want to put some information. Suppose on this axis we have plotted intensity, and on this axis we have plotted phase. So phase difference and graph is coming like this: cos square phi upon 2, graph is coming like this. Graph is the language of physics, because suppose we have taken here phase difference, this is phase difference, right? So if phase difference is 0, phi is 0, I resultant was 4 I naught cos square phi upon 2. So if phase difference is 0, I resultant was I1 plus I2 plus twice root I1 root I2 cos phi. So if phase difference is 0, so I resultant will be what? Root I1 plus root I2 whole square. So these are the points where phase difference is 0. This is 0, phase difference 0. This is a point for phase difference pi. This is a point for phase difference 2 pi. This is a point for phase difference 3 pi. This is a point for phase difference of what? 4 pi. And this is a point for phase difference of what? 5 pi. So on this we have plotted phi, and if we plot path difference, so this correspond to path difference of what? 0. This correspond to path difference of what? Lambda upon 2. This correspond to path difference of what? Lambda. This correspond to path difference of what? 3 lambda upon 2. This correspond to path difference of what? 2 lambda. Okay. And this correspond to what? 5 lambda upon 2. Okay. So here, this is a top point where you are getting what? Imax. And Imax is root I1 plus root I2 whole square. Okay. And this is your I mean. This is your I mean. And I mean is what? Root I1 minus root I2 whole square. Okay. And this is your I1 plus I2. This is your I1 plus I2 common factor. So what extra for Imax? This is plus 2 root I1 I2, and this is minus twice root under I1 I2. Okay. So from the expression, I is equal to 4 I naught cos square phi by 2 for two sources having I1 and I1 is equal to I2 is equal to I naught. It is clear that I naught is the intensity produced by each one of the source individually. If the phase difference between source S1 and S2, that is phi, is time dependent, then the observed intensity will be given by what? This. And this is, we have already talked about average. So average intensity denotes, here we have already discussed average. So the average intensity, this is average intensity. This is average intensity. So this denotes the time average of the quantity inside the angular bracket. Okay. And clearly, if phi varies in a random manner in time, then cos square phi upon 2 will randomly vary between 0 and 1, and we all know that the average value of cos square phi upon 2 is equal to what? Half. And for such a case, I is equal to 2 I naught. Okay, which implies that If the source are incoherent, then the resultant intensity is the sum of two intensities and there is no variation of intensity. Thus, if one or both of the two vibrating sources are turned on and off in a random manner such that the phase difference between the vibrations of the two sources varies rapidly, then the interference pattern will not be observed. Here we have taken words sources, types of sources, so I just want to discuss about them. One is coherent source and other one is non-coherent source. If you desire sustained interference, if you desire sustained interference, so sustained, what is sustained? Sustained interference. Sustained interference means pattern is not function of time. Interference pattern does not vary with time. That is that is once pattern developed, it will remain fixed. It will remain fixed. So sustained interference is also known as a stable interference, and also known as steady interference. Steady interference. Now the condition for sustained interference. Condition condition for sustained interference. So condition of sustained interference is that first, the interfering waves must have same period and wavelength. That is the source must be coherent. Okay, and monochromatic. That is the source should emit light of single wavelength or very nearly monochromatic. Second condition is that the two interfering waves must be in the same state of polarization. Okay, now I'm going to discuss coherent source. What is coherent sources? Coherent sources. Two sources are said to be two sources are said to be coherent if they vibrate with a phase difference fixed phase difference between between them, that is the phase difference introduced between them at a given point of a space is independent of time, that is not function of time, independent of time. So result y1, suppose 1 is y1 and this is a1 sine omega 1 t minus k1 x1 plus phi 1. This is wave 1 and this one is wave 2. This is a2 sine omega 2 into t minus k2 x2 plus phi 2. So of course phase difference is what? Phase difference phi is equal to omega 1 minus omega 2 into t plus k2 x2 minus k1 x1 plus phi 1 minus phi 2. Okay, and I have stated that phase difference should not be function of t. Phi should not be function of t. So of course this term will become what? This term will have to be 0. So omega 1 minus omega 2 into t must be 0, which implies omega 1 will be equal to omega 2, and which implies frequency nu 1 is equal to frequency nu 2. So two sources will be coherent if their frequencies are same, as well as they are what? Monochromatic. Okay, so nu 1 is equal to nu 2, lambda 1 is equal to lambda 2, monochromatic. Okay, so I want to tell one more thing, that we have discussed this graph. In interference, energy is transferred from the region of destructive interference to the region of constructive interference. That is, only redistribution of energy takes place and energy is neither created nor destroyed. That is, law of conservation of energy holds. Okay, so these are the basic things which we all have to keep in our mind. And one more thing I just want to put here, and that is this one is, this was your graph, right? And this was taken as intensity on this axis. So we have taken a very small elementary area d phi. This is d phi. Okay, so this one is 0, this correspond to pi, and this correspond to 2 pi. So the average value of the intensity. The average value of the intensity on the screen over the range phi is equal to 0 to phi is equal to 2 pi may be given as I d phi upon d phi, and this will turns out 2a square 1 plus cos phi d phi 0 to 2 pi and divided by 0 to 2 pi d phi, and this is equal to what? 2a square. So clearly average value of energy over any number of fringes in the same is the same as if the interference effects were absent. That is, there is no violation of law of conservation of energy in interference pattern. So these are basic things which we have to hold in our head. Thank you so much to all of you for showing your